6.2 talks about volumes by slicing. We have the following three cylinders, say quarters. If I want to find the volume, I'll simply say take area of the base times the height. If I was to take this same quarters, and put them out of sync, assuming they have the same height. So assume these are the same quarters. I just put them at different heights. The volume will still be the same. I'll have to take the volume of the first, volume of the second, volume of the third, and add them up. But if I line them up and they happen to line up like that, where it is a cylinder, I simply take area of the base times the height. And we know that the base in this case is a circle. The area is pi times r squared times the height. Where here I have to do pi r squared h for that, plus pi r squared for that, plus pi r h squared for that. Now, suppose we have a function, and the function looks something like this. And suppose I rotate this function about the x-axis. So, let me be more specific. I'm not very specific. Here we go. If we have a function, I misspoke. If we take the following area, not the function would just be the line. If we take the following area and rotate it about the x-axis, what would happen? It will create an identical copy that looks something like this, and it will occupy all of that. As this rotates so fast, it's going to create like a solid jar. Well, unlike these problems, here, I'm going to call this x sub 0. I'm going to call this x sub n. I'm going to take x sub 1 to be right there, x sub 2, x sub 3, x sub 4, and then it goes on. Well, if I take x sub 1, if you look at this piece, it's going to create a cylinder where the radius is x sub 1. When I get to the green piece right there, now this is going to create the base. Okay, that doesn't look very pretty. Here we go. So it's going to look like this. If I put it face down. Now, one thing you might be wondering, and I want to make sure you understand that, the radius is x sub 2. And if I look at the blue, there's the cylinder, and that radius is x sub 3. And of course, if I go to the very last one, okay, that's not registering, here it is. That last radius will be x sub n. Now, I want to make sure that we're clear on why are those not straight. That's because this is a curve. It's not a straight line. So when you go here, you'll notice that these are not straight lines. Notice here I'm picking my rectangles perpendicular to axis of rotation. So if I pick my rectangles perpendicular to the axis of rotation, this is what I'm looking at. I'm looking at the volume roughly being this. Volume would be roughly volume 1 plus volume 2 plus volume 3 plus volume n. And each of those volumes, if you really think about it, that is really area of the base times the height. Now the height is really delta x, nothing more, plus area of the base times the height, plus area of the base times the height, and the list goes on. Well, first base, second base, third base, nth base. Well, so isn't area of the base can't I say volume is roughly the series I equal 1 to n of a sub I dx? And if I take the limit as n approaches infinity, that would be the integral from a to b of the area of the base times the height. And that's pretty much what this section is going to be above. Now you do notice that if I pick my rectangles perpendicular to the axis of rotation, you'll notice that we're talking about that area being the area of a circle, and the area of a circle is pi times the radius squared. Now the question is, do you have a disk or do you have a washer? And I'll point those out as you do every problem. The key, we pick our rectangles perpendicular to the axis of rotation, and you're going to be able to see the disk slash washer right in front of you. So here we start with the first problem that says, here we are. For the following exercises, draw the region bounded by the curves, then use the disk method. Disk method means you're going to pick your rectangle perpendicular to the axis of rotation. Well, we're going to rotate this about the x-axis. Let me center that really quick. So, x plus y equal 8. Let's say that is 2, 4, 6, and 8. Y, x plus y, so this is 8, 2, 4, 6, 8. It's a line. But we are chopping it off at x equals 0, y equals 0. So we're talking about quadrant 1 only. We're talking about this region. And we know that this is x plus y equal 8. We're going to rotate this about the x-axis. What's going to happen? It's going to occupy that space. And as this rotates so fast, it's going to create a cone. It's going to look like this, right? Well, all what we care about is we're going to take out our piece, a rectangular piece right there. It has to be perpendicular to the axis of rotation. As this rotates, it's going to create an identical copy right there. And we could see the actual circle right there. So we're looking at a circle, and the outer circumference of that circle is the purple color. And the radius in this case is the distance from the x-axis up to the function. So remember, it's always top minus bottom. So if I solve this for y, the radius is 8 minus x. Volume would be the integral from a to b of a of x. And in this case, since we picked this perpendicular to the x-axis, that's dx. If it's dx, then we know how that works. We're going to integrate from x equals 0. We know this is going to run all the way through 8. And the area of that piece is simply pi times r squared, but the radius is 8 minus x squared dx. So at 0, the radius is 8. You could see that. At 1, the radius is 7, and the list goes on. So we run x from 0, that gives me a radius of 8, all the way through 8 until we get to the end. And I'm going to assume that you know how to integrate that. If I say setup, do not solve on a test, this is what I want. Of course, that's the integral from 0 to 8. Pi is a constant. If you FOIL that, that's 64 minus 16x plus x squared. And that will be pi times 64x minus 16x squared over 2 plus x cubed over 3, evaluated from 0 to 8. Plug the 8, plug the 0, and there it is. So I'm going to leave the answers like that, assuming you could integrate. Almost none of those will require even a U sub. Now, I know Pasadena City College students are not responsible to know the integral of E, but for practice, let's set up the integral anyways. You could. I'm looking at the graph of y equal e to the x plus 1. So e to the x passes through 0, 1. This passes through 0, 2. So the graph looks like this. X equals 0. X equal 1. Let's say that's 1. And y equals 0. They're talking about this region. I'm going to rotate this about the x-axis. What's going to happen? This is going to create an identical copy like it right there. And it's going to occupy all of that volume, the whole solid. If I pick my rectangles vertical, because I want them perpendicular to the axis of rotation, I'm only, and that makes this, since it's vertical, that's a dx. So I know x runs from 0 to 1, and it's going to be pi times the radius, pi times the radius squared, because we know that as this rotates, I could see right here, the purple is the outside, and the circle is going to look like this, where the radius is simply that distance. So you take top minus bottom. Top will be e to the x plus 1, oops, minus 0. So that area right there is simply pi times r squared. And assume you could work that out. You could FOIL that. Again, Pasadena City College, you're not responsible to know how to integrate that. And of course, I'm not going to ask you to set it up either. But for practice purposes, you could just look at that. Cal Poly students, we know how to do all of those. Y equal radical x, 0, 0, 1, 1, 2, 3, 4, 1, 2. There it is. X equals 0. x equal 4, and y equals 0. So we're talking about this region. I'm going to rotate this about the x-axis. That's going to create an identical copy like it right there. And it'll occupy that part as well. If I pick my rectangle perpendicular to the axis of rotation, well, hey, that's a dx because it's vertical. It's sideways, it's dy. That's going to create an identical copy right there. And I could see that this function is going to be the outer rim of the circle. Now you're not going to know pretty much why I'm saying that until you see the washer. Then you figure out what I'm talking about. And the radius is pretty much, if it's vertical, top minus bottom. So that's radical x, integral. This is going to run, since that's a dx, it starts at 0 and it terminates at 4, kind of like area. But now I want the area of this. What's the area of that? That's pi times the radius squared. And again, I'm going to assume you know how to do that. That's simply pi x. So pi is a constant. Add 1 to the power, divide by that, plug it in, and there's your whole problem. Actually, I can work this one out really quick. That is pi times the integral 0 to 4 of x dx. That is pi times x squared over 2 evaluated from 0 to 4. That is pi over 2 times 4 squared is 16 minus 0. The whole area volume is 8 pi. If I take those two lines, if I take y equal x plus 2, let's say that's 2. I rise 1, I run 1. Here we go. Okay, what's up with these circles? Okay, so assuming that's 1, 2, 1, 2. And if I take this, which starts at 6, 2, 3, 4, 5, 6, rise 1, run 1, rise 1, run 1. There it is. We're going to take those and we're going to cut them off at x equals 0 and x equal 5. There we go. Now, I'm only interested in that piece, and I'm only interested in that piece. We know that this is x plus 2, and we know that this is x plus 6. I don't need the lines. And we're chopping it off right there at 5. The region in question is right there. Now, since I'm going to rotate this about the x-axis, this is going to create an identical copy like it right there. And that's going to create an identical copy like it right there. And it's going to occupy that space. Now here, as this rotates, when I pick my rectangle, I notice that there's a gap. This is what's famously known as the washer. I have one of those, but there's a hollow part inside, and that's the green function. There's a hollow part inside, so we're trying to find the area for this. And this is the washer, of course. So to find this, just like area, we say the integral. Since we picked it vertical, it's a dx. We know it is 0 to 5. You start at 0, you turn at 5. Now, the outer, that distance is x plus 6. So the area of the whole thing is pi into x plus 6 squared. And the inner is the green. So if I subtract off, if I take the area of the purple, it's going to find all of, oops. If I take the area of this, that's going to find all of that. If I take the area of the green, and subtract the two, by subtracting this part, that's going to give me the area that I want exactly. And that's how it works. There are no shortcuts to this. Do not try to get a shortcut out of this. You'll mess it up. So always take the outer area minus the inner area. No exceptions. Here's another one. If I want to take y equal the sine, so that goes up 1. That's 2 pi. That is pi. And you notice they're going to chop it off at 0 and pi. So we're going to stop right there. Now this graph right here, you go 5, 1, 2, 3, 4, 5. So the region in question is right there. Okay, you know what? I'm going to rescale this really quick. Let's say that's 5. It's not going to change the nature of the problem. But when I rotate this about the x-axis, it's going to create an identical copy right there and an identical copy right there. And it's going to occupy that much space. As this rotates so fast, I'm going to draw my rectangles perpendicular to the axis of rotation. We see that there's going to be a washer because that's going to be hollow. Well, on the washer, the outer is simply that distance. That distance is 5 sine of x. If I say volume equal the integral from 0 to pi dx, and if I take that area right there, that is pi times 5 the sine of x squared. And if I notice that, oh, okay, does that a lot. Oops. There. I notice that the hollow part is the green part. So if I could go ahead if I find this area, which is this part, that's pi times the sine of x squared. And if I subtract the two, I'm left with the yellow. So the green part will be taken out, and that'll give me the actual washer area that I want, which is okay, which is just this. Now, of course, as you rotate about, you could rotate about the y as well, and that's going to change. You need everything to be in terms of y. So, it's not y equal anymore, it's x equal. If I look at the following line, and I rotate that, so let's say that line, y starts at 4. Let's say that is 1, 2, 3, 4. And you rise 1 down, 2 to the right, 1 down, 2 to the right. So the line, and we're going to cut it off, x equals 0, y equals 0. So you're talking about quadrant 1. So we could figure out what that point is. Where does that equal 0? When x equals 8. Here we go. So if I take this, and I'm not going to rotate this about the x-axis, I'm going to rotate it about the y-axis. That's going to create an identical piece like it. And it's going to occupy that volume. Now I pick my rectangle perpendicular to the axis of rotation. It's in terms of y. So it's y equals 0 to y equals 4. Versus if it was vertical, that would have been 0 to 8. Pi times the radius squared. As this rotates, it's going to create a disk right there. It's not a washer. So all what I need to do is figure out what this is, and this distance is right minus left. Keep in mind, if y equals 4 minus 1 half x, that means 1 half x equals 4 minus y, and x equals 8 minus 2y. So that will be the radius of that circle in terms of y. So you cannot have a dy and an x in there, or a dx and a y in there. That's not allowed. So make sure that you solve accordingly. The next problem as well, we're looking at y equal 3x squared. That's a parabola. X equals 0. X equals 0. And y equals 3. And the graph 0, 0. When x is 1, y is 3. So we're talking about this region. I'm going to take this and rotate it about the y-axis. That's going to create an identical copy like it right there. Occupy that much. And as this rotates, I'm going to pick my rectangles perpendicular to the axis of rotation. Well, that's going to create that disk, and that distance is simply right minus left. If y equals 3x squared, since I'm picking this horizontally, that's a dy, that's y equals 0 to y equals 3, pi times the radius squared. Well, the radius, I can't put an x in there, say 3x squared. I'll say y over 3 equals x squared. X should be plus or minus the square root of y over 3, but in quadrant 1, it's the positive radical y over 3. And you could work this out really quick. That is pi times the integral from 0 to 3. When you square a radical, it cancels out. So that's pi over 3 times y squared over 2 evaluated from 0 to 3. Pi over 6. 3 squared is 9 minus 0, of course. So that is 3 pi divided by 2. And this problem, again, we're looking at, we did something like that before, but let's make sure we see it. Radical x 0, 0, 1, 1, 1, 2, 3, 4, 1, 2. This should continue, but we're going to chop it off at x equal 4 and y equals 0. We're talking about this region. We're going to take this and we're going to rotate it about the y-axis. It's going to create an identical copy like it right there. And if we pick our rectangle, again, perpendicular to the axis of rotation, we know the color didn't register. Okay. Now, we notice that volume is going to be the integral, and it's going to be with respect to y of y equals 0. Now let's see, if we put x equal 4 and y equal radical x, that makes it y equal 2. So a big difference. And it's going to be, we notice that in this case, the outer rim is the green. And the green, that distance right there is right minus left. That is x equal 4 pi times 4 squared. But the hollow part is right there. That's the purple. And that distance right there, which is the radius, I can't say radical x. Remember how we put x equal 4? If y equal radical x, square both sides, x equal y squared. To find this area, you take the whole thing, which is the green, and you subtract off the purple, which is pi times y squared. And there it is. That will find me the volume. And that's pretty much it.